Good afternoon, everyone. I'm thrilled to have a chance to speak with all of you today. I want to change gears a little bit and talk about interactive ebooks and how they pertain to coding. So many of you may know that Rosen Digital has an award-winning series called Spotlight. We have a brand new product that I've been working on for the past year or so that I'm very, very excited to present today called Spotlight on Kids Can Code. Now, those of you who know Spotlight probably are very familiar with it in terms of science and social studies. The platform lends itself beautifully to coding, and that's really what we wanted to tackle next. So you might be asking, why coding, first off, and I'm going to piggyback on some of the terrific statistics that Kathleen shared a little while ago. There are 500,000 open technology jobs in the U.S. today. Within the next 4 years, their number is going to double. So we're going to be talking about not 1 million jobs, 1 million open and vacant jobs, high-paying jobs that pay 50% more than the average private sector jobs. There's been a recent analysis that found that nearly half of all the jobs in the top quartile in pay require some computer knowledge, science skills. So we all know that there's a huge demand for this. Right now, I have 4 children that range from 12 to 3. I think about when my 3-year-old is entering the workforce, what that workforce is going to look like in terms of technology jobs then, and the need for students that are trained in coding and computer science and computational thinking is staggering. So how do we meet that need when we know that only 40% of K-12 schools right now are offering even a single computer science course? This program, as well as many of the others that you probably already know about and that you might hear about today, aim to meet that. And before we jump in there, let's talk a little bit about computational thinking in particular and why it's valuable, because computational thinking is more than computer science, it is more than coding. So when you think about computer science, what many of us think about is coding, but it is much, much more than that. It's more than programming a computer. It's thinking at multiple levels of abstraction. It's all the things like sequencing and planning and organization that Kathleen spoke about a few minutes ago. And this analogy that you see at the bottom of the slide is one of my absolute favorites, and I think it really gets to the heart of why computer science and computational thinking are important. They are as important as, or if not more important than, learning to code. So just as a kid playing Guitar Hero isn't a musician, someone who can play with code isn't a computer scientist. They're not necessarily skilled in computational thinking in the way that we need tomorrow's students to be. The drag-and-drop coding apps are terrific, and don't get me wrong. As I said, I have 4 kids, and they love them. I think there's a lot to be gained for that. But what we want to do is go a little bit deeper and try to help students understand, okay, I'm dragging and I'm dropping and I'm making things happen, but why is that happening? And how can you predict what's going to happen next? And how can you organize your thoughts and plan in a way that you're going to kind of bring all of that coding together, add a computational thinking aspect to it, and be able to really begin to develop a solid understanding of computer science. So the first thing that I want to say to those of you who are not doing coding or any kind of computer science with your students yet is conquer your fear. When I was looking around, I saw this cartoon a couple weeks ago, and I thought it was absolutely brilliant. Even those of us who work in technology sometimes are intimidated to bring that technology, to try to teach it to a generation that are truly digital natives that seem so comfortable with that technology. Kids Can Code was created explicitly in a way to help educators become very comfortable with the material no matter what their level of expertise. So you may be a veteran teacher of computer literacy. You may be brand new to all of this and thinking, what do I do next? But I'm going to show you some basic instructional support material that's going to take you through, kind of take you down that path and show you everything you need to know. So first, what are we talking about when we talk about Kids Can Code? You'll see here there are 14 titles that are currently available. I'm going to talk about the interactive ebooks today, but these are also available in print. They talk about specific programming language, like things like Hopscotch, Lego Mindstorms, the always famous Minecraft, and so on. They also talk about components of computational thinking like debugging algorithms and simulations. And then coming in August will be 12 additional titles. So let's talk a little bit about the key features of this interactive ebook program. So the first thing that I want you to recognize is that we're looking at computational thinking and coding in general from a historical perspective, starting at the foundation of the particular language, for example, moving up to today. So we have things like timelines, and you'll see here in our Minecraft book, we have a timeline that shows the history of coding and also the greater context of history. So what's happening in the world as computer science is really emerging as a discipline. We also have interactive Q&As throughout the book. These are a mix of fun facts that students can learn about, interactive quizzes where they can test their knowledge, interesting little features like the term debugging came from what creature? It came from a moth, actually, and a moth was caught in some of the machinery, and they pulled out the moth and it began to work again, and thus came the term debugging. Here you'll see it. We have a clickable left nav that has a number of different kinds of content. So there are biographies of key computer pioneers. These are role models or inspirations for aspiring computer scientists, programmers, entrepreneurs. There is a heavy emphasis on biographies of women who have been involved in the computer science field. And then we have primary sources and more about articles that really enrich the learning, pull out features that we think are of most interest to students. So this little box, which is kind of hard to see, shows one of the first computers. This dates from 1950. At the time, this was the largest, fastest computer in the world. So if you look right here, you'll see that certainly despite the fact it probably doesn't have as much processing power as the iPhone that's sitting on your desk, it is much, much larger, and at that point it was the fastest in the world. And this is something that students just eat it up. They love to see these kind of interesting tidbits. We also have activities, and these are hands-on unplugged activities that I'm going to get into in a little more detail as we go further along. So just kind of hold this thought for a minute, and I want to show you a bit more, a few slides from here. Next up are videos. So we want to make sure that we're supporting learners in multiple diverse learning styles. So there are videos peppered throughout the books. In this case, you can see a video of a 3D printer. And then all of these are narrated with actor-narrated audio, which is incredibly important, again, to support learners with multiple learning styles. There's just really no substitute for actor narration, particularly when we have a lot of terms, sometimes some code, some jargon, so that you can be sure that students are getting the information they need and it's all clear and it's accurate. So the built-in instructional support is one thing that makes this program so unique and so powerful. First, let me say that this program, Kids Can Code, was created as a direct response to the new K-12 computer science framework and the ISTE science standards for students. So it is intended explicitly to support both of those. If you are trying to find out exactly how to integrate these new standards into your classroom, this is a terrific tool for that. You can integrate them into the classroom or the library using Kids Can Code. It's really, it's a nice stopgap measure if you're just trying to figure out. Some people I know have told us, we're scrambling. This is one way that is really very much a grab-and-go piece that you can add to your classroom, you can add to your library, and you can begin supporting these standards with your students right away. These are available throughout the book. So if you look here in this left nav, you'll see that there are planning guides, there are lesson plans, templates, and so on. And let me click a little further to give you a better sense of what is in the instructional support. Every book has the program has approximately 30 unplugged activities. These were created by Christopher Harris, who is the library director for one of the New York State BOCES. He is an expert in the field of gaming in particular. He has done a lot of work on gaming in libraries, using technology in libraries and other technical educational resources. So we worked very closely with him to create these activities. They range from activities that one student can do alone at their desk to an activity that an entire class can do together. They're phenomenal and so much fun. I will tell you, you'll see all these animals here. He's created a game called Go Code, which is very much like Go Fish, but it teaches some of the basic principles of coding. Another example down here is a grid that a librarian would actually print out the pages of the grid and build their own grid on the floor, and students use simple code to move one another around the grid. Those are just two examples, but I can't emphasize enough just the uniqueness and the richness of this. We wanted to make sure that it was clear that this is fun above all else. Coding is exciting. So rather than sitting in a screen and dragging and dropping, rather than worrying about equity of access and access to technology, because we know that those are issues, and there's a lot of programs out that already do those things, we wanted to build something different and something that really supported the unplugged movement. Last, I'm going to talk for just a few minutes about some of the features and the functionality of this program. So just nuts and bolts. These are one-click access through MARC Record, so they're very, very simple to use in your library. They are unlimited simultaneous access, and they're one-time purchases. They are also updated as technology changes, so despite the fact that they're a one-time purchase, if something happens in terms of a certain programming language, for example, the content is updated to include that material, so you're really sort of getting that for free after the fact, which is always nice because this, sometimes material dates quickly, and people worry about a one-time purchase. So, we want to make sure that you're comfortable that we're updating on a regular basis. It is responsive design, so you can use it on a smartboard, on a laptop, on an iPad, on an iPhone, on an Android device, anytime, anywhere. We integrate with Google Single Sign-On. So if you're in an institution that is configured to use Google Single Sign-On, we can certainly support that. And I just want to mention briefly, kind of get back to where I started, we also have an additional 12 Spotlight programs. So those of you who know and love our existing Spotlights, things on science and social studies, this is built on the same platform. It functions in a very similar way. So if you're used to using these programs, there's really no training required. It's all the features that people know and love adapted to coding.